Okay, so we're going to take a look at these transcendental functions, and then we're going to deal with differentiation today. All right, now, it's going to be logs, basically, functions that have to deal with logs. So you've got to remember all those little things about logs that we did last year. All right, so let's put review, and I'm going to do this very quickly because I think that once I do like a really quick example, then you're going to get it, okay? Do you remember the jump the frog? Okay, jump the frog. We're going to be jumping the frog a lot, okay? Obviously not a known math book principle, but let's suppose we had like 3 out in front, natural log of x, okay? Jump the frog means what? He goes up on top, and then that's equivalent. So I could go natural log of x to the third. And then it works the same way, right? I can put him up on the log because he's sunning himself, or he can jump out down into the water and cool himself off. Remember the story from last year? Okay, so that we will use a lot, okay? We will use expanding our logarithms, because what they're going to do is they're going to give you logarithmic problems that are relatively complicated, and you don't want to do the traditional quotient rule or the traditional product rule. You're going to want to simplify it with your log rules and then apply the new logarithm derivative that I'm going to show you. Okay, so how do we do this? If it was the natural log, say, of an x square root of, an x squared plus 5. You remember how to expand that? We had a rule that said when I'm multiplying something, I can expand it and make it out simpler and write it as the sum of 2 logs. So I could go log of x plus log of an x squared plus 5 to the 1/2 power. All right, but to make it even simpler, we're going to want to pull that down in front. So natural log of x plus a 1/2 natural log x squared plus 5. And that's what you're going to want to do to these expressions in order to make them simple for us to take the derivative. Okay? And then the other one, let's do, like, say, natural log. Here, let's go square root of, say, an x minus 1 over an x. So the first thing I'd probably do is get rid of that radical, right? So I'd probably go natural log x minus 1 over x, and then that would be to the 1/2 power. So I would probably simplify that from radical to exponential form. Then I would jump the frog to get rid of it so that I didn't have to mess with it in front, or in the problem. And then when we divide, what's the rule? When we divide, we subtract our logs. Remember that? So 1/2. And then let's go ahead and put a bracket here. Natural log x minus 1. And then minus natural log x. Okay, so is that enough? Do you remember doing this last year? And the expanding is what we're going to want to do. Last year we also compressed and we did some other things. All right, but the expanding is what we want, because the goal here is I don't want to mess with this problem in this form because it's too complicated. If I can expand it down to here, once I show you what the derivative rule is, really simple. All right, really complicated. It doesn't look that complicated, but when I expand it out and I get down to here, I can take the derivative really easy. Okay, so that's the whole point of that. Okay, all right, so there's your review. All right, so real quickly, let's do the derivative. Okay, so our derivative of our natural log function. So I'm going to do it in terms of u, where u is a function of x. Okay, so we're taking the derivative with respect to x. I'm going to go ahead and put square brackets around just because the formula in your book does it that way. Natural log of u, okay, where u is a function of x. U is a function of x. It's been a long time since we've done this, so I'll go ahead and write that down. Okay, so formula, new one you got to memorize. So if we do some more memorization formulas, this will be on here now. U prime over u. It's literally that simple. U prime over u. So whatever the inside portion of the log problem is, derivative of that over the original u. So do you see why if I've got something like this, this is my u, Derivative of that real quick, 2x. On the bottom, x squared plus 5. All right, this, complicated. But this, I can take the derivative of really fast and really easy. Okay, so that you got to memorize. Put that in your little bank of things to memorize. So let's just do some example problems. Let's say my original function, let's go really super easy. All right, natural log of 2x. All right, I want you to be able to do this in your head. All right, so the inside portion of this log, the inside portion of the log is 2x, right? So there's my u, that's my u. Okay, so derivative. I want you to just be able to look at the 2x and go, derivative of 2x is 2. And the u on the bottom, 2x, simplifies down to 1 over x. So that's kind of easy, right? Now, you're also going to have to implement this inside product rule. You're going to have to implement this inside chain rule. You're going to have to implement this in quotient rule. All right, all of them. So let's suppose I had an x natural log of x. All right, so that's just good old-fashioned product rule. Okay, so inside our product rule, I'll be taking the derivative of that natural log function. All right, so first term, x. All right, now, if you want to go back to the d dx notation, you can. So d dx of natural log of x plus natural log of x times d dx of x, which I really wouldn't need to do. That's just a 1. All right, but if you want to throw that d dx notation back in there that we had done earlier in the school year, you're more than welcome to do that. All right, so this stays an x. All right, so inside part of my function is x. So derivative of x is 1. That goes on top. And whatever the u is goes on the bottom. So derivative of natural log of x, 1 over x. Plus natural log of x. All right, well, what's x times 1 over x? 1, right? So then this goes down to 1 plus natural log of x. So you taking the derivative of your natural log function inside product rule, inside quotient rule, inside chain rule is going to happen. All right. Let's do one more because I think I can squeeze it on right here. And then we'll move on. Let's say I've got the function natural log square root of x plus 1. I'm going to rewrite with log rules first. All right, that doesn't look that complicated, but I don't want my u to be the square root of x plus 1. All right, I don't have parentheses around that, but I could. All right, I don't want that whole u thing to be something that involves chain rule. I want that u part inside here to be as simple as possibly can so I can take the derivative in my head. So, natural log x plus 1 raised to the 1/2. If you need to show that step, jump the frog 1/2 natural log x plus 1. All right, now that's really easy. And I don't even have to do product rule because this is that constant in front of the function, so constant multiply rule. So when I take the derivative, I can just have 1/2 times, and then where's that inside function? See, we want that inside function right there to be super easy. So derivative of x plus 1 is 1, and then over x plus 1. All right, and then you could clean that up because that's a little tacky. Maybe something like 1 over. You could distribute the 2. You wouldn't have to distribute the 2. Okay, but I didn't have to do product rule. Could I have done product rule? Yeah, 1/2 times the derivative of that plus natural log x plus 1 times the derivative of the 1/2, which is 0. So that's why I didn't bother to do it, right? Constant multiply rule. It's been a while since we've done that. All right, you can do product rule because that second term always falls out because this is a constant, where you can just know it falls out and not mess with it. Okay, so straightforward. That pretty simple? Okay. I can also, you know the famous question of write the equation of the tangent line at a given point? So now I could give you this type of function and ask the same question. Okay? Because before, what did you have? You had implicit differentiation for your function. You had nice little polynomials. You had close, things that we had been working with. So now, same question, I can give you a different type of function. Okay, so your derivative is different. All right, so we're not going to do one of those. All right, what we are going to look at next, though, is something called logarithmic differentiation. Now, we're going to implement this. Again, we're going to choose this form of differentiation when the problem is too complicated to do quotient rule or product rule nice and neat. All right, you don't like, or I don't like personally, to do quotient rule if I got chains floating around everywhere. All right, so if I've got a complicated algebraic expression, I can use logarithmic differentiation to make it simple, and then I can take the derivative of a natural log function. Now, there's going to be steps. All right, step 1, it's going to be 5 steps. Take natural log of both sides. You're going to take natural log of both sides of the equation. All right, then you're going to use your log properties to simplify. Third thing you're going to do is you're going to then differentiate, and it is differentiating implicitly. Okay, so we're going to say differentiate implicitly. Okay, then we're going to simplify. I don't know that that's the best one. Is that the best one? Is that my next one? No, I don't like the simplify. Take the simplify one out, because I'm kind of making this up. Differentiate implicitly. I could have left simplify in there, but I'm thinking that's going to be common sense. All right. My whiteout's not wanting to work. All right, let's make the 4th step solve for y prime. Would be substitute y back in. Take the log of both sides. Use your log properties to simplify. Take the derivative implicitly using the little formula that I showed you. Solve for y prime, plug in, y back in. And if you go through each one of those steps when you do a logarithmic differentiation problem, you're not going to miss anything, because this kind of tells you exactly what to do, what to line out here, okay? All right. Now, from there, let's take a look at what this is going to be. Okay. Let's suppose they give you f of x is equal to x minus 2 quantity squared all over the square root of an x squared plus 1. Now, technically, if you didn't know what logarithmic differentiation was, you all would just do what? Quotient rule, right? But quotient rule on this one might not be massively bad, but you're going to definitely have a chain down here in the bottom, okay? You're going to have a chain up here, but the chain's just a 1. All right, so if this was a little bit more complicated, if this was a little bit more complicated, all right, it could be kind of nasty. And with this, you're going to have a raised to the 1/2 power, so you could have some negative fractions in there. So it's just to make this simpler. Now, the catch is, on the ACP exam, they're not going to let you do quotient rule, because the directions are going to say, use logarithmic differentiation to find the derivative. So then they're going to force you to do logarithmic differentiation. Okay, I don't have a y. First thing I said was, well, take natural log of both sides. Well, I can't take natural log of f of x. All right, so I'm going to switch that to a y and take the natural log of both sides. So I'm going to do natural log of y, natural log x minus 2 to the 2nd power all over the square root of x squared plus 1. All right, now, second rule, use log properties to simplify. So I've got a quotient, and I want to jump the frog, right? I want to jump the frog, so I'm going to be jumping a frog there with a 2. I'm going to be jumping a frog there with a 1/2. All right, left-hand side I'm not doing anything with. So it stays natural log of y. All right, natural log of that top. When I jump the frog, the 2 will be in front, and then it'll be an x minus 2. All right, can I do that quickly? Are you guys all good with that? Okay, all right, I didn't want to skip too many steps or go too far ahead, and I'm a little OCD. That was too far over. Okay, all right, I see a quotient, quotient, means subtract, so subtract. All right, same thing with this one. If I pull that up to a 1/2, I jump the frog, the 1/2 is going to be out in front. 1/2, natural log, x squared plus 1. So there's where your pre-calc comes into play. All right, now, differentiate implicitly. Okay, that means I got to slap in the y primes, right? So when I do the natural log of y, derivative of y is 1 y prime, implicit. So y prime goes on top, and then y goes on the bottom. Because that's a natural log function, remember, and we're doing that u prime over u. Okay, so there's my u. It's a 1, y prime goes on top, y on the bottom. Okay, now this one, I'll have a 2, all right, that'll be multiplied by this, but derivative of that inside is 1 over x minus 2, and then times the 2 that's in front. Derivative of the inside, 2x, don't let me screw up, all over the x squared plus 1, and then I'm multiplying that by 2 there in the front. Okay, good so far? All right, now you got to solve for y prime, but what do I got on this side? I've got fractions. I can cross out those 2's right there. I got to have common denominators, don't I? Okay, so my least common denominator is going to be an x minus 2 times an x squared plus 1. That's my least common denominator. So this fraction needs to be multiplied by the x squared minus, or x squared plus 1 over x squared plus 1. This fraction's got to be multiplied by the x minus 2 over x minus 2. So I got to get those common denominators on that side. I'm still going to leave my y prime over y on this side. All right, the only thing I got here is 2. Can I distribute on top? Right there. So I'll have stop me when I lose you. 2x squared plus 2. All right, this is a binomial. I'm going to be distributing that x, but it's negative x. So negative x times x would be minus x squared. Don't let me screw up the math. Negative x times negative 2 is going to be plus 2x. Everybody good so far? Because all this is your algebra. And then all over my least common denominator, and I'm not going to do anything with it. I'm just going to leave it. I can combine some like terms and simplify a little bit here. So I'll have a y prime over y. Crap again. Almost forgot my over y. X squared plus 2x plus 2. All I did was combine those like terms. X minus 2. Don't let me screw up. X squared plus 1. So all of this, I took the derivative from here to here. That's the only calculus in that problem right there. All right. From here to here, that's all pre-calc. I took the derivative right here implicitly. That's the only calculus in this problem. All right. All of this is algebra manipulation. I got to solve for y prime. So what am I going to do? Multiply both sides by y, because we're not done yet. Multiply both sides by y. Multiply by y. Multiply by y. These y's cross out. Don't have enough room. I'm going to do it this way. Okay. Now, take a look at what you got over here. I got this great big expression times y. I've solved for y prime. That was step 4. The last step says substitute y back in the problem. All right. So my final answer is going to be, I'm going to come all the way down here so that I can pull that down a little bit. Y prime is going to be equal to, leave this yucky thing, x squared plus 2x plus 2 all over x minus 2 x squared plus 1. Okay, now replace y. Okay, well, come back up here. What was my y? My y is this. So I'm going to replace that y with x minus 2 to the second power all over the square root of x squared plus 1. Now, technically, that is your answer. Now, could you manipulate this and simplify? And yes, all right, I'm going to grade this if you get to that part right there. All right, you get to there, then I know, don't I know you just did all the 5 steps, right? So you've done the problem right. Okay, now, is there a lot more that we could do? Yeah, I could cross out x minus 2's. I could make this to the 1/2 power. And then 1 plus 1/2 would be 3/2. I mean, that wouldn't be too hard. Want to do that real quick? This crosses out with one of those. This, if I rewrite to the 1/2 power, this, don't I have like bases? When multiplying like bases, add the exponents. So then I could have something as simple as an x squared plus a 2x plus a 2 on the top with only an x minus 2. And in my denominator, I could have an x to the 2nd power plus 1. What do we say 1 plus 1/2 is? That's like 3/2. Or the square root of that raised to the 3rd power. So see, I can get all the way down here. And what I might do is I might go bonus points for simplifying the algebra correctly. All right, but if you get to this point before we start simplifying, then I know you did the 5 steps right.